Hello viewer, welcome back to KSP Contracting. I'm Lorenzo, this is episode 6, and here we are in the tracking station joining the fine folks at the tracking computers, determining our next mission. In the previous episode we went to Minmus. Seanman is still stuck there, but that doesn't matter because he's in his cozy capsule. We can go get him whenever we feel like it. So before we continue, let's get the asteroid of the episode out of the way. We'll have this one, that's a planet. Let's see. We'll have that asteroid. It's another C-class asteroid. Let's track that. And are we going to get in trouble with that? Doesn't seem like it, but it will get really close to us. So that's interesting. Space objects. Oh, this new category. Oh, this is a flag. I was gonna say just Minmus count this as a space object. Unknown. I want to find a category for asteroids. That's what I'm doing here. Is space objects? Yeah, space object is a good category for asteroids. Because today we're going to go to an asteroid, and we have one that is going to be close to us. Yes, this one will enter our sphere of influence in 19 days. Or does that say 18? Anyway, 19 days. And we can launch on day 150. By the arbitrary rules that I set. So let's fast forward and see whether we want to launch on that day 150 or maybe at a later date. So here we go, 40, 48. We have day 151 and we can now launch. And it does seem as though this asteroid will go through a fairly equatorial orbit. Go through a fairly nice, easily accessible place around Kerbin, and it will get there in about 16 days. Now just to be prepared, I think we're going to launch now and then fast forward to when the asteroid gets there, so that whoever's at the controls will have some time to, get ready and stuff. So the question then becomes, what are we going to send? And we are still working with the same garage of stuff as in the previous episode, because I recorded this one pretty much straight after. In the previous episode we launched the Rainbow Express. I'm going to delete that because, it's launched, it's spent. So we have the choice of the EFS Peregrine, the Green Spotted Jaguar, the Greiswolf Zero Asteroid Whacker. The problem with the Zero is that it's unmanned, and I would like to get a man over there to do some science. Now we could make this a two-part mission where this asteroid whacker whacks it ever so slowly and actually puts it in an orbit around Kerbin. This does seem to have the punch for that. Or we could go with a manned launch and see if we can get a guy there near it, which we could probably accomplish. Oh, I should delete the Green Spotted Jaguar as well, awesome as though it was. I think I'm torn. Manned or robots? Smacking or studying? What do the aesthetics of the craft say? This looks like a lander. This could land somewhere as well. This could go and get... No, this couldn't get Sean Mus. Forgot his name again. I do forget the names of these astronauts in trouble. This couldn't get him because it doesn't have 2 seats. So that's something you could do. Design a craft with either an empty pod and a command probe, or 2 pods or something to get the guy off Minmus. For now though, I think we're gonna go with the unmanned asteroid whacker and see if we can gently get that asteroid to be close to Kerbin to make it accessible for further study or even retrieval. So let's get with the Zero. This was made by Greiswolf Industries, otherwise known as Rule, and let's give that a go. Let me just check my mailbox to see if there was some nice flavor text with that while we roll it out to the launch pad. And here we are on the launch pad, and this note is attached to the rocket. It says, "Panic! Dear KSP, we noticed an asteroid heading for our headquarters. Have our biggest rocket, our secret emergency launch pad is broken because somehow plowed some space debris containing a lot of fins for some reason into it yesterday. Please help us." Reward: if you manage to redirect the asteroid with our Zero, we will donate one of our janitors to serve as Kerbinaut at your space center until death. +1 astronaut. remarks that this beast should have 1400 units of liquid fuel left once in orbit. It has enough punch to gather some speed before slamming into something. No Kerbal needed. Right. I'm probably not going to go for the massive super slammer, but to go for the gentle touch and controlled redirect. But let's first see how this fares under thrust, and there it goes. Wow, that really does take off rather rapidly. It might even require some throttling to not slam into the air at velocities that are too great to be called efficient. And let's do that. Stick it around. Let's aim for about 100 meters per second at this altitude. Screw it, full throttle. I do like how these submissions with the text make it a little bit roleplay with rewards, corporations, and different brands of rockets. So definitely keep that up. I do always get a chuckle out of the funny ones, which so far are all of them. Although I must say I don't think I'm gonna allow the Greiswolf janitor at our space center. Just because, oh look, we are at a staging event. Let's do that. Oh dear. Well, I saw an explosion, but it seemed as though everything is going fine. I'm not going to allow the Greiswolf janitor to be anywhere near the space center, because that guy is definitely a spy. There's no way around that. He is going to steal technology, and I don't know what he's going to do with it, but he's not janiting my closets. No, he's not allowed on the base. So thanks for the offer, but we will do it with our 10 astronauts that we have remaining. One on Minmus, he needs to be retrieved, but we've got 9 more on the ground, and that's plenty for now. So thanks, but no thanks. Okay, let's pitch over. Let's do an aggressive 45-degree turn, as we're used to doing in the stock system. It always breaks my soul a little bit to do this, and then, you know, it's so unelegant, but yeah, you know, efficiency. After this stage, what will happen is that these 3 side boosters will fall away. Then we have this center stack remaining. That will get us into orbit and then some. And then we have here some asparagus, well not asparagus, but onion staged boosters to get to the asteroid and to move it once we get there. It's a C-class asteroid, so it should be fairly possible to impart some delta V to it. We don't have the claw, obviously, but these landing legs appear nicely placed just to, you know, push against it. We'll see how that goes. We have solar panels, so we won't run out of electricity, although they are on the top, and if there's a big asteroid here, they might be occluded, but we'll see how that goes once we get there. Or, as is more eloquent to say, we'll cross that bridge when we get to it. So, coming up on stage separation here, these tall outer boosters are going to fall away. It's a little bit scary whether they're going to hit the center stack. I hope not. So there we go. Whoa! I don't know what these explosions are upon separation, but something explodes and then everything is fine again. Now we have a lot less thrust, but we are at 30 kilometers, going at about half orbital velocity for this small planet, so that should be fine. From here on out, I think the orbital insertion will be fairly predictable, so I'm going to cut the video and reconvene with you once we are in space and orbit. So here we are in space at the booster burnout, and we are almost in orbit, which incidentally makes this a very nice and clean launch system, because this will fall back and this will establish orbit. There we have it. 90 kilometers periapsis, that's in space, and we have 1714 units of fuel remaining, so that's a lot. Wonderful. Do we have fuel lines? This all seems to be connected properly. We have batteries. We don't have a battery, so a momentary occlusion will drain our controlling capabilities. We'll just have to hope that these solar panels still receive light when at the asteroid. Also, rotating the asteroid could probably be tough with these, well, landing struts as connectors. We'll just have to see how that goes. Speaking of the asteroid, let's fast forward time and have a look at its approach, because that should happen in about 15 days. 15 days mission time. Is it this one? Well, we'll just have to go and see. So let's time warp. Oh, we can't time warp faster than 100 times. Guys, I suppose we have to wait for a few hours. Oh no, we can just go to the tracking station. Let's do that instead, shall we? where we shall track the asteroid. Can we rename it? Not from here, I don't think. This is the one, 16 days. Can I quick save from the tracking station? Don't know. I wanted to do a quick save to see if I overshot it with this time warp here, that wouldn't ruin everything. So there we have it. Ooh, there might be a problem. It is in a retrograde orbit compared to us. That's not actually that big a problem if we want to just hit it, but if we want to match speed with it, ooh, this is going to be a challenge nonetheless. We can do two things now. First of all, let's switch back to the ship. We can do two things. We can try and hit it like an impactor at a few kilometers per second. That will be fun, but that will preclude the ability to do any meaningful science. Well, we can't do science with this anyway, but we might as well hit. There is the possibility that we'll hit it on an impact trajectory, which of course would not reflect too well on our space program. So I think. Let's first make sure that that's actually what's happening. Yeah, this thing is coming from this direction, and we are orbiting counterclockwise. Damn it! I seem to run into this problem a lot. Yeah, we're just going to hit it. We're going to hit it dead on and hope that that imparts enough of a velocity change to capture it and to make it be an orbit. And it will be a nice mission because this will be something that, well, I at least have never done before, trying a high-speed rendezvous instead of a, well, typical slow-speed rendezvous. It means that this plane align maneuver has to be very accurate because, well, we want to hit it and we're going to be fast when we do it. So the nodes here read 180 degrees because of course our planes are aligned, but they are flipped in one axis because we will be going the other direction. That is completely fine. The plane change will take 1200 meters per second, and then the rest can be used for acceleration purposes and last minute course corrections, or last hour, last day course corrections. This is going to be exciting. We're going to hit an asteroid and we're going to hit it fast. This should have a lot of delta V still in it, so yeah, we can hit it really, really fast. And there's not a lot more that I can say about that than that we're going to do it. And then the next mission we can probably go and get... Oh shit. I want to do this plane change maneuver, but will my electricity run out? Will this last 5 minutes? Will this last 5 minutes? I hope it will. I think it won't. I'm going to wait until the last second and then light the engines. Here we go. I think it will last 5 minutes, only just. Yeah, we've got 1 unit of electricity and the burn happens in 20 seconds. Wonderful, great timing. Some batteries would be nice, but you know, we don't need them, so, well, no harm done. 1000 meters per second, this rocket takes care of that, no problem. And then we have to alter our orbit to basically overlap this one, but faster. This is going to be fun. I think I'm going to do that by putting the apoapsis at that orbit's altitude, and then once there, just boosting straight for the asteroid. And then saving some fuel to do course corrections on the way. Because this asteroid is small, it's like a 10-meter target. Look at that. Okay, we can immediately start raising our apoapsis, of course, because we're at an almost circular orbit. Let's see... I think that this is a good starting point. This is a good starting point, and then we will be heading mostly straight at it. Yeah, and then we can just start heading straight at it. And then I'm thinking I'll save some fuel to boost more along the way, and by keeping some fuel in reserve, being able to make final course corrections, that will make me hit it. This is going to be difficult. What will probably happen is that we'll zoom past it at 100 or 200 meters, or a kilometer, or something like that. But that should still be worthwhile. Right, so that should put our orbit at an asteroidy altitude. Let's boost that a little bit higher still. Ooh, let's keep it here. Let's keep it here. Right, so I'm going to time warp until this point. Let me actually use a maneuver node to grab that point, stopping the time acceleration. Intersect 1, add a maneuver, and we're just going to overlap that onto the asteroid. And the intersect plotter should help us here, because that will be able, well, if all goes well, that will be able to tell when we will intercept the asteroid. But I wouldn't be surprised if this like high-speed impact scenario was not part of its programming. Let's see. Well, that seems to be overlapping it, of course. Oh no, it doesn't. It's hard to see if these lines intersect in 3 dimensions on a 2D screen, obviously. So let's see. Yeah, this is pretty good. This is pretty good. Let's go with this first and time warp up until there. 3 hours at 1,000 times makes that just under 30 seconds, which should be alright. No, it's less than, well, I don't know. Can't do math faster than the time acceleration, which is fine because we've got computers for that. Right, so 17 seconds on this burn, and that should leave us still with plenty of fuel for the corrections. Where is our asteroid? It is over there. DCO 635. Ideally, of course, we would want to whack it at its periapsis, but we can't do that because we're headed for it now. So it will. I bet you we're even if we're even going to hit it, I'm predicting that we will just hit it into a Kerbin impact trajectory. Wouldn't that be funny? Anyway, the robots are taking over. This is a robotic spacecraft after all, and we shall see how this works out. So burning for asteroid impact. So that's our 3 side boosters gone. Just these 2. Oh, I'm getting a phone call, so I'll pause the game and record. There's that taken care of. I've got 12 more minutes before I have to run off now. And let's focus on more important things and look at this asteroid intercepty burn. You might notice I'm not aiming straight at the asteroid now. That's because we're still close, well, relatively close to Kerbin, where the gravitational space warping will affect our trajectory. And that's fancy talk for I have absolutely no idea where the ship is going. So let's give it a little bit of time and see how these 2 objects approach each other. And once we're like through this hairpin turn, we can... Ooh, we don't have a lot of time to do that. We're just going to do it like we would rendezvous from a distance, from a close distance, basically burning to try and pull this prograde vector onto the target reticule. We're just going to head straight for it. And hopefully that works. This is difficult and we're doing it with no planning. So success has to be guaranteed, right? I reckon this is a good intercept vector. And I think my flight computer does not agree. Look, these lines are not going to be close together at all. So let's time warp forwards a little bit more. Ooh, god damn it. What is a good way to make sure that we are actually going to hit it? I don't know if there is one. So we need to go way more this way, probably. I have absolutely no idea. Well, I'm just going to ignore the map view completely and just trust that this reticule is actually accurate, and I'm going to keep burning to keep it on target. To basically just keep heading for it as fast as we can. So I am going to peek at the map screen to see whether by how much of a margin we are actually going to zoom past the asteroid. Then again, maybe this is working out. it looks as though it might be working out. Are we within visual range yet? Probably not. Let's have a look. Are we still in time warp? We're still in time warp. Let's have a look. Let's modify this vector a little bit again, adding ever more speed onto this train wreck. That's the reticule centering on the target again, cutting engines. And as soon as it's in visual range, I'm just going to burn all the remaining fuel. And if you're wondering, but won't it be better if... Ooh, well, this thing is going crazy, and that's probably a good sign. Isn't it better to hit it with some more mass than with more speed? The answer is a resounding no. We want to go as fast as possible, because kinetic energy in a projectile is, well, the exact is, I think it's like E is mv squared, which is energy equals mass times velocity squared. So you decrease a first order term, but by adding speed you increase a second order term, which explodes the energy exponentially, which is good if you want to hit something really hard. So that's why we are not saving any fuel as ballast for impact weight. We are going for a full-on high-speed super collision. And I wonder if we're in visual range yet. When will we be in visual range? I am super excited, by the way, if you can't tell, whether we're going to nail this multi-kilometer per second hit. 1,000 times time acceleration. We're getting really close now, I think. The target reticule is still on target. This, by the way, is one of the missions that the Chinese recently talked about, of sending a light impactor at a solar retrograde orbit, so that's massive amounts of delta V, to hit an asteroid head on in the case, oh, something happened, we passed it. It didn't work. Damn it. It didn't work. I think it zipped through visual range real quickly, because I didn't see a yellow reticule. Maybe that was my fault for being at 1,000 times time acceleration. Maybe I shouldn't have done that, because the closing speed was about 3 kilometers per second. We'd be in range for a 200 kilometer stretch. That means just under a minute, just over a minute. At 1,000 times time acceleration, that's less than a second. Damn it, that was stupid. Let's see, is there a quick save where we can try this again? Yes. Ooh, this is still a while back. We get the second shot. Hey, and look at that. Maneuver nodes persist through quick save. So I'm giving myself a second shot at this, mostly because that was just really stupid to spend so much time at a high time acceleration. And also because this is KSP Contracting, where it's fun and whimsicality that's more important than accuracy and first shot wonders. So we're just going to do this again. Although, if you recall, I just got a phone call. I have to run off to one of the hotels to sell some excursions, which makes me happy because I work partly on commission. And that means that I'll reconvene with you once we're at a somewhat similar point in the approach trajectory where we might actually even see the asteroid. So see you in a few seconds, which will be an hour or so for me. Bye bye. So here we are, and as promised, I am back after several hours. I have no idea what we exactly were doing when I left, but let's just deploy the landing legs to be sure. Impact absorbers, I'm sure they will be able to withstand this multi-kilometer per second impact if we even manage to make it happen. Look, we have a nice intersection again, while the maneuver node discos think we're gonna pass by either 50,000 kilometers or 21,000 kilometers. I don't think it's gonna be that far either way off. These lines still don't cross, but if we look here at the nav ball, we're lined up pretty well. So, far as I can tell, we're doing well. So, let's try time warping again, but this time while looking at the map view so we don't accidentally overshoot. Also, I'm going to throw in a quick save here, so that if we do overshoot, because I am impatient, we can correct things from slightly earlier. Look at that. Is that going to go well? I have trouble even estimating that. We are still bang on target though. Let's just correct our vector using the nav ball. We need to go to the left and up a little bit. And remember, we are hitting a target at, let's say it's 10 meters, which is, I think, is fair for a C-class asteroid. going at, well, let's say we'll be going at 3 kilometers per second when we hit it. That means we've got our target cross section is 1/300th of the distance we cover in a second. I don't know how that translates to accuracy, but that number must be astonishing. And we're doing it basically by eyeballing it. In this field of view, this asteroid will appear at some point, and then it will be passed in less than a minute. So actually there is some time to see it coming, and well, whether we'll be able to do anything about it is anyone's guess, but I hope that we'll at least be able to see it coming. So let's time warp a little bit more here on the map screen and see if we can make it hit. So the velocity vector is still pretty much bang on target. I want a larger nav ball. I'm gonna go into the settings and see if I can make the nav ball larger. Those settings are only available through the main menu, so I'm not going to bother with that for now. I just have to stick my head closer to the screen. I think maybe we can go a little bit this way. No, now it's too far off this way. There's almost no way we can hit it at this high a velocity, but we're gonna try anyway. Another quick save, and let's punch the time warp up to 50 times. Is it getting closer? It is. We try 100 times. Back to 50. Here we are approaching it. It will appear to be in front of the rocket. I mean, we are that precise. It's not going to show up here or something. It is going to appear here. I think. Go on, appear. How far away are we? Ooh, that's 100 times again. Go on, asteroid. Where are you? Show up, please. 10 times acceleration. We're drifting off course now. Time for another course changing burn. Let's do it this way. Has got to be quite a big one. Oh, stop. If you hadn't figured it out yet, I'm trying to get the dot of this pink target heading marker to be in the dead center of the vector marking, so that we're heading straight towards that asteroid, so that we may hit it. That's, well, it's not exactly hard, but it's hard to do it at the precision that I think will be required, which might very well exceed the amount of a pixel here on the nav ball. If someone could do that math, that'd be funny. I think it could, because we're going in at such a high relative velocity, and the target is so small that a deviation here that is smaller than a pixel might be too much. But I'm not sure about that, because that's just a guess. Anyway, this line is definitely crossing now, so we at least have a fighting chance. And there's those magic words again. At least we have a fighting chance of an impact. I'm attempting some time acceleration. Just a sedate 5 times now. Because I want to see this asteroid. How close a pass are we going to manage? That is the question. 10 times now. It should come into view. Go on. Where is that asteroid? There it is. Reducing the time warp. Oh dear, there it is. It is approaching rapidly. Ooh, and we're not on target. Go on, burning towards that. Full speed into the asteroid. No! Oh, we missed it. I feel like trying again. We need to hit it, and we need to do course corrections up until the moment we hit. I want to nail this. We came within like less than a kilometer, I think. I think I saw numbers flashing past that indicated less than a kilometer, but I am not sure, because flash past they did. Right. Fortunately, as we do get closer to the asteroid, the nav ball does get more accurate. Funnily enough. Right. I'm going to pop a quick save. No, I'm going to time accelerate until we see it. Or until we see this indicator drift noticeably. Okay, I'm going to pop a quick save. I'm going to try not more than once more after this, promise. So that was the correction. We need to go up slightly. That was a correction. I'm just pretending by now to do precision control of this impactor rocket. Let's time warp a little bit more till we can see it again, because that makes things interesting. We need to go this direction just a little bit. Again, ooh, there it is. There it is. Approaching rapidly. What direction is this indicator moving? This way. We need to go that way. I can't see it. I'm getting the optical effect where I stare at the dot too long and it vanishes. We need to go this way just a little bit. Full thrust. Ah! That must have been really close. Okay, one more time. Okay, this time we're just going to increase thrust this way. I was staring only at the nav ball, didn't even see how close we got, if we got close at all. Full thrust. No, we're going to pass it on the wrong side. Full thrust this way. Full thrust. Oh god, we're gonna miss it. 7654. That's way further off the mark than we were the other time. Okay, one more. One more. Oh god, how am I ever going to nail this? I'm going to try and do corrections only close to this and change it as I go. And after this, if it doesn't work, I'm going to enlarge the nav ball and see if we can make it better like that. Okay, full thrust this way. Okay, that's in the middle again. A little bit of thrust this way. A little bit of thrust up. Ooh, ooh! I saw the asteroid then. That was close. Right, okay. One more time with a gigantic nav ball. Okay, as promised, here we are. The nav ball is now larger. Also, that has somehow destroyed the frame rate. But here we go. Let's see if we can get that on target again. Oh no, we need to load the quick save because this is already past now. Right on. Let's see if we can get that on target. I don't know how or why, but the large UI seems to have destroyed the frame rate. Oh well, we're just gonna try one more time anyway. As if. Alright. I'm thinking this way slightly. But not a lot, remember? Just slightly. Ooh, need to go up now slightly. It changed. No, we need to go up by a lot. We need to go this way. Stop. That's bang on target. I'm thinking we need to go this way ever so slightly. 15 kilometers now only. This way ever so slightly. This way a lot. Ooh, that was so close. That was so close. Okay, one more. I don't know what I'm gonna do if and when we actually hit it. Okay, this way. There. Maybe we should just not make any corrections, just keep it like this. You would laugh if you could see me. I'm like leaning forward and all the way up to the screen to, you know, see it. Okay, okay. It's in the center. It's almost in the center. We need to go this way ever so slightly. Ooh, yeah. Oh, yeah. Oh, yeah. No, we need to go left and up. Not by a lot, but by a bit. By a lot. Oh, darn it. One more. How? Is there a better way to do this? Is there? Ah. Okay, now for this go, I'm just going to keep the engine running all the time. And that's probably not better, but it will give us the maximum impact speed, and maybe I'll be able to fine-tune it better by steering as we go. And that has to be the stupidest thing anyone has ever said in the whole asteroid program. But yeah, here we are, centered on that asteroid. There we are. Coming in for an impact. This feels better though. It most certainly was worse. Okay, one more. Only one more. And well, at least we promised we have enough fuel to basically burn the whole time until it gets here, so that's good. If I just lock it, and by orienting the ship pointing towards the asteroid and just locking its attitude there, maybe that, it's still a few hundred meters per second of delta V, maybe that locks it in by enough, but still the target is so small. Here we go. No, that didn't do it. This time I'm not going to enable SAS, but just going to aim it at the center, and then when I'm happy with the course, then I'm going to enable SAS, because that previous time it wobbled. Also precision control, something that we could use, I think. Okay, it's locked on the asteroid. It's locked on the asteroid. It's locked on the asteroid. I'm going blind again by staring at a spot. It's locked on the asteroid and SAS on. Keep it there, please. Accelerating at 5 Gs towards the asteroid. No. Move it. This doesn't work. Precision control. Precision control is required. Yeah, and then when you start veering towards it, that doesn't work. Okay, the full thrust while pointing at the asteroid, that doesn't work. Right. It should give you a closest approach ever, like a high score, because this feels like an arcadey high score game now. Okay. Am I happy with the trajectory? I am happy with the trajectory, like so. Is it changing, and if so, in what direction? Okay, stare mode engaged. Staring at the nav ball. Is this screen of any help? No. This is not telling me closest approaches for like meters. This way. Full thrust engaged. Keep it like this. Oh god, we're gonna hit it. Oh! We didn't hit it. Okay. Promise. This is the last go. And then we're gonna move on. Maybe you should just do nothing. No. This is the go where I do nothing, and then there's gonna be a last go. Wouldn't that be funny? That this quick save had the collision course the whole time. That would be funny. Let's hope it is like that. It's looking good so far. 46 kilometers. Still pretty central. Ooh, I should orient the craft like this, so it has a slightly larger chance of hitting it. Yes, why not? Here it goes. Here it comes. 8 kilometers. Ooh, that's pretty good from the quick save. What? Maybe I should just use that and just thrust If only I could remember which way the ship was pointing, and only thrust like this way for a tiny, tiny amount. It's pretty good, so I can make a quick save from like 40 kilometers. No, I can make a tiny bit of thrust. We can inch it closer. We can inch the quick save closer. This is going to miss. Still very, very close. Yes. Oh, I completely lied. No way that was the last go. We're gonna inch the quick save closer. I think that's a wonderful term. Okay, okay. So here it's good. Here it's good. Okay. I'm happy with the trajectory here at 80 kilometers. So quick save. This is going to be a mighty fast reaction game though. Let's just see to which, let's do nothing but rotate the ship and see on which degree it passes, and then I'm gonna just do 1 meter per second towards that direction. I think we need to burn this direction. That's 90 degrees. Yes, we need to do 90 degrees. And how far does it pass? We need a kilometer more, and that's about, okay, that's about 1,000 meters, and we have about 30 seconds. So let's try 2 meters per second. 2 meters per second towards the 90 degree heading. So how are we going to gauge that? Target relative speed isn't a good one, but we're gonna use it anyway. Quick save now. Okay, let's see how that goes. Oh, we need more. We need more, don't we? How close is that going to be now? It's going to be close though. The next burn will happen in the alternate universe. Oof, that was so close again. The next burn will happen so somewhere like 50 degrees, and it's going to be a small burn. Okay, okay, so this way. Oh, I'm spending too much time. So something like this. Full thrust for a bit. This isn't gonna count. This isn't gonna be a quick save. Ooh. Okay, we can routinely see the asteroid now. Okay, I have to be quicker on the burn. Going to go for 5 meters per second or something like that. Okay, okay. Quick, 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 quick. Burn and quick save. So hopefully this is going to be really close. Otherwise we messed up the quick save, and if we mess up the quick save now, then well, then we might just as well quit. So, oh god, no, that was so close. Okay, okay. Slight, just a bit more of this burn, but not a lot. Okay, let's see how that goes now. And as soon as the asteroids start passing on the other side, then we know we're really close. Oh god, okay. That didn't seem substantially closer than the other one. So let's do a slightly longer burn, like so. And as soon as the asteroid passes on the other side, then we're gonna do the trick where we point towards it and just burn full throttle, because then we know that we might be able to narrow it down by a decent margin. I should stop quick saving though, because it's already really, really close. Okay, so like this. This is probably too much. No, it's not too much, but it was really close. So we can experiment with burn durations from here. Okay, so burn to until the target relative speed says 56.2. Let's see how that goes. Oh god. That was so close. We need more though. So let's go bigger increments. Let's go 60-ish. Yeah, like that. Okay, okay, here it comes, here it comes. It is now passing under us. Okay, 60-ish, and then turn towards it and full boost into it. Full boost into the asteroid. Okay, that's 60. Where is that asteroid? There it is. Full boost into it. Okay, that's not a good solution. Which way is down here? That is okay, we can quickly swing the ship around to like 50 degree-ish and do that. Okay, new plan, new plan, new plan. Okay. We go a little bit of... Ooh, that's a lot. Let's see how that goes. Or did we go up now? No, we need to go the other way. I think that was really close. Let's see, how far does it go in a frame? If we have 30 frames per second, that means it goes 100 meters per frame. Oh shit, can we even hit this? I think we can't. We do get really close on this quick save though, so let's just thrust a slight amount more, like this, and then more quick saving, and see what we do now. I think we might be physically incapable of hitting it. Ooh, let's do a little bit more thrusting. Oh no, if it is actually impossible, even though all this effort happens, that's sad. That's really sad. Oh. Okay, more thrust. And no more quick saving, because now this asteroid is already at like 10 kilometers as soon as the game loads. I don't think I have time to steer anymore. Oh god. Yeah, I think this is as close as we're gonna get. If it goes 100 meters per frame, I don't see what we're gonna do. And I could have worked this out like a million years ago, but I didn't. So let's try and see instead how close it actually gets. How close we actually get to it. Okay, that's 7, that's 5, that's 3, that's 2, that's 1. Yeah, we get within like 100 meters. And on that, I can't even call that a bombshell. That's more like a fizzle. I will end the episode, and I will also throw the quick save online. So if you want to have a go at this from 10 kilometers away, let's see how far away does the quick save load. Yeah, about 10 kilometers at 3 kilometers per second. So you have a whole 3 kilometers. Oh, it's so close. You have a whole 3 kilometers to a whole 3 seconds to adjust your heading speed and course. Oh, it's so close. I want to keep trying, but I know it's futile. So, going to head to the Space Center. The next launch will... Well, I want to say it's going to save Seanmus, or whatever his name is, but I don't have any two-seaters yet, so that's off the books until that happens. The next launch, I'm going to evaluate the ships and see what's going to happen. Maybe another astronaut, maybe a manned astronaut. A manned astronaut. I should stop talking. Maybe it will be a manned mission to an asteroid. Anyway, thanks for watching. Keep those submissions rolling in. Enjoy it as always, and see you next time. Goodbye.